Hi fellow geek, welcome to this problem solving session. So today we are going to solve a very interesting problem on CodeChef, which is called Sereja and votes. The problem code, as you can see on the screen, is SEAVOTE. So I'll drop the link to this problem in the description box below, and I'll suggest you to try it for yourself once, and if you get stuck, or maybe if you want to have a look at an alternate solution, then you can refer to this video. So without further ado, let's start with the session. So I have actually divided the whole problem solving procedure into 6 major steps, and we are gonna go according to those steps. The first one is understanding the problem statement and its constraints. Second is finding a logical approach / algorithm. Third is improving upon the algorithm that we found in the second step. Fourth is actually coding our algorithm into our preferred language. I'm gonna code in C++. Fifth is debugging the code that we have written. It can be through sample test cases, or if we can come up with different test cases. And the sixth is actually the most important. It's summation of the problem. Let's have a look at the problem itself. So we are gonna actually do 2 readings of the problem statement. In the first reading, we'll actually try to understand and get a rough idea about what the problem is all about, what it is asking from us. And the second reading, it will be more like extracting the information present, so that we can move to our second step and start finding a logical approach. So about the problem statement, Sereja conducted a voting about n of his opinions. AI% of people voted for opinion number I. This statistics is called valid if sum of all AI is equal to 100. Now let us define rounding up of a statistics A. If AI is not an integer, it will be rounded up to next integer. Otherwise, it will be left as it is. Now let us consider a statistics B of size n, in which each of bi is an integer. Now he wants to know whether there exists some valid statistic A of size n which may contain real numbers, such that after rounding it up, it becomes same as B. Okay. Now we'll try to extract as much information as possible from the problem statement. Now we are given n opinions. So n here can be thought of as entities, and for each of those n entities we have a value associated with it, which is AI in this case. And now what we are also given is that the values associated with each of the entity sums up to 100. That is, so now we can think of it in terms of an array as an array A of size n, consisting of elements as A1, A2 till AN, and the sum of all those elements, as we have mentioned here, is 100. Now we are also given the rules for rounding up. So the first rule that we are given is, if A of I is not an integer, then a of I will be rounded up to the next integer, and if a of I is an integer, then it will remain the same. So now with this information, supposing that we have integers as well as non-integers present in the array A, we can have a new array A dash with n elements, and with each of the element rounded up as required. So now the thing that we should understand from this is that it was given that sum of all elements in the array A is required to be 100, but once it's rounded up, it can be more than 100 as well. Now the next thing to be considered is another array B of size n consisting of some integers and only integers, unlike A, which can also consist decimal numbers. Now what is asked from us in simple words is array B equal to A dash of n, which is nothing but the rounded up array we got from A of n. It's said in the question that whether there exists some valid statistic A of size n which can be rounded up and it becomes same as B. So if there exists an statistic of size n which can be rounded up to be same as B, which we can see from this relation is actually true. So now that was all about the problem statement. And now if we talk about the constraints, so the test case is variating from 1 to 50, and the number of elements is variating from 1 to 10 raised to the power 5, and the range of each element, interestingly, is variating from 0 to 10 to the power 3. So we are given this array B, and we need to find out that if there exists an array A which can be rounded up to this array A dash and B same as array B. So now since as we have read the problem statement and we know that 100 is actually the threshold value, so I'm going to consider 3 cases based on this. Case 1, when the sum of all elements in the array B is less than 100. Now this is a known fact that before rounding up even, the sum of all elements of A needs to be 100. So if after rounding up the sum is coming to the total of 100, then it's a no. I mean, there is never a possibility when sum of all elements of B is less than 100 for an array A to exist. So this case will always produce an output of no. Now case 2 is when the sum is always equal to 100. Now we know that A can have all integers elements, or it can have all decimal elements, or it can have both integers and decimal elements. So in case when the sum of all elements of V is equal to 100 and P can only contain integer elements, then we can understand from this that all those elements as it is can be present in the array A also. So it's always a possibility that if the sum of all elements of V is equal to 100, then there will always exist an array A which can be rounded up to form this array. So it's always yes. Now comes the third case, which is when the sum of all elements of V is greater than 100. Now this is an interesting one because it will require us to see how much actually the sum is greater than 100, because with that knowledge we can actually calculate that how much for each element present in array B we need to subtract to get to 100. What I mean by that is, suppose we have 4 like as an element present in B. So now it can variate from 4.1 to 4.9. What I mean from that is that it can only variate in the range of 4 and from the range 0.1 to 0.9. I mean, it can obviously be 0.000 and I can use as many zeros as I want, but that variation can never exceed 1 because then it will move to the next integer. So what I'm saying in this case is that we need to find the difference as the total sum of B minus 100 will give us how much the sum actually exceeds 100, and after that we need to divide this difference by the number of elements present in B so that we can get the maximum variation that needs to be produced in each element to get to 100. But as we have seen in the constraint that B can also consist 0 as one of its element, that's why we also need to keep a count of the non-zero elements. So suppose we have a variable each well which will actually consist the value of diff divided by count of non-zero elements. Now each well comes to be less than 1, it means that we can do it because we can have a variation less than 1. But if that variation exceeds or becomes equal to 1, then we cannot do this variation. See, what I mean by variation here is actually how much we can subtract from each number, because sum is already exceeding 100. So we need to subtract from each value to be able to reach 100. And that's why we first of all calculated the difference, which is nothing but how much the sum is exceeding the 100, and then we calculated the amount that we need to subtract from each value, which we calculated by the difference divided by the count of non-zero elements. So why we took a count of non-zero elements and did not include every element as such? Because we cannot subtract anything from 0 in this case, because this will become negative and we do not want that number to become negative. So that's why we cannot make any variation or subtract any quantity from 0. So it was no point in including 0 in our count. So that's why we only took the count of non-zero numbers, because then we can subtract, and also we can only subtract quantities less than 1. That's why we are checking if the value of each well comes to be less than 1, then it's a possibility, then we can have a statistic A. So this is one thing we need to understand. So now we are finally gonna code the approach that we have thought about. So I'm gonna do the coding in C++. So I'll include the header files necessary. And this is actually just a template that I keep always. So first of all, I'm defining the test cases. And now I'm defining n, which is the number of elements, and with n I'm also defining the count of non-zero elements and giving it the value 0. And with n defined, I'm going to define the array B, which will consist n elements. And now I'm gonna take input for this array. But before that, I also have to define a variable sum, which will keep track of the sum of all elements of P. Yeah. So we take input for each element and also sum each element, and if b of I is greater than 0, then we also increase the count by 1. So we now have this. Now, as we discussed, if our sum, I forgot to declare a result variable which will be of type bool, and I'm giving it a default value of false, which will allow us actually to not even consider the first case, which was when sum was less than 100, because it will be a default case. So when sum is equal to 100, we'll actually change the value of result, that is RES, to true. And now if sum is greater than 100, and in this case we'll need to define two more variables, one for the difference which I don't think will be double. No, it will not be double, rather it will be long. And yes, we also need to define a variable to keep a track of the variation required in each element. So now diff is calculated as sum minus 100, and for each well we'll have nothing other than diff divided by count of non-zero elements. Now if each well is less than 1, then RES will become true, otherwise it will remain to be false. So I am guessing that's it. Yeah, that's it. So if IS is true, then we output yes. If not, then we'll output no. And that would be the end of this question. So our program has compiled successfully. Now I'm gonna run the sample cases which are given to us. I'm gonna see if it works well for the sample cases. I'm gonna paste them here and it works. I mean, don't go by the indentation, it's because I copy pasted the cases. It's no, yes, yes. So now I'm gonna go and submit my solution and see if it works or not. So I paste it here and I click on submit. So we have successfully completed this question, and with that this session also comes to an end. So stay tuned for some more exciting problems. Till then, keep coding.